I would like to introduce Ilker Alisi, and again, Mauricio Rojas will be here later. They'll be presenting a network automation in light of model-driven management. Ilker is a regional product manager and a senior consulting engineer for Nokia based out of Sunnyvale, California. And Mao is a network automation regional product line manager at Nokia based out of Richardson, coming to us from Texas, of course. This is Ilker's second time actually presenting at NANOG. He actually was doing the tutorial, or part of the tutorial, at the last NANOG we had. And this will be Mao's seventh time presenting a tutorial session here at NANOG. So please welcome Ilker. He'll come up and do the first portion of this. And it's a pleasure to have you back again for the second time, and we'll go from there. Thank you.
Thanks so much, Steve, for introduction. I always love to be at the NANOG events, meeting with folks like you and then sharing the information based on the same interest, common interest. So thank you so much for coming to Kansas, and welcome to my session. First of all, before we just jump into the agenda, I would like to ask how many of us really think that we are adapting the network automation to today's regular tasks that we take? Is there anyone really focusing on the network automation and use it day-to-day operations? Perfect. And how many of us really would like to understand from scratch to the more, deeper steps for the network automation, and for that goal that we are welcoming you here now? Awesome. Okay, so this will be the tutorial, and the actual goal that in my mind was starting a little bit, short journey through time, starting from the past and then to the present, to understand how we really have an evolution on the network management. And then we will start with the key blocks. All that blocks will show us what exactly the fundamental steps that we use for the network automation. We will talk about the new and modern network management interfaces. And then we will talk about the open source ecosystem, for the automation, how we can leverage the open source ecosystem. And then we will just combine all those blocks by representing them with the demonstration, even for the lab deployments, and then the other construction. So the first demo will be end-to-end deployment that provide us a platform to automate the operational tasks in the network. And the second part of the demonstration will talk about, again, the open source solution that we utilize Kubernetes to extend your network lab beyond a single node. If you want to have, more scalable network to do some, test experiments, that will explain that. So we all know that more than 30 years since when I was in the primary school, primarily the network management rely on CLI or traditional legacy protocols such as SNMP. So these protocols and methods are severely limited. For instance, the CLI is vendor specific. It lacks hierarchy of the data. Even for the same vendor, different products may have a different hierarchy, CLI schema. And those actually developed primarily for as a human interface. And then we know all the SNMP. I'm not really, judging the SNMP. It's still good, but he is suffering major scale issues. And it's complex. The OID is 1, 2, 3, 4, 5. It's hard. And also, SNMP is not really right fit to configure the stuff, right? Oh, sorry. It needs to go further. So, on the other hand, the increasing number of the network devices that we have to deal with, services and configuration, the modern network became very complex. And then manual management to deal with this complexity is time consuming and as well as error prone. So on the other end as well, the service providers and operators, they are demanding more agile, faster network operations. So it's been proven that for the last 5-6 years, at least, I would say network automation help at that stage address that challenges the operator has. So what is the network automation? It actually refers to delegating network tasks as much as possible to the software, applications, machines. It allows structured data and then the standardized API to interact with each other. So we need to have some tools to be able to do the complex job in a short time frame. Otherwise, we're going to drop the watermelon and we will have the catastrophic accidents in the network. So the goal is, again, we would like to delegate the operations to the machine, to the softwares to provide the machine-to-machine communication. Here is the key factor, having a structured data and then API. So structured data provides standardized and organized way of modeling our configuration and state and operational data. And in the meantime, standardized API help us to communicate, set up the connectivity between the different applications. Based on these standards, we will be able to create a consistent communication between our software and then applications. Having the structured data is important from the programmability perspective. If you know what will be the input, then you will know the output. That makes us predictable outcomes, and then developers, programmers will be easily program and then help those programmability to automate the task in the network. So we talk about the structured data. Well, we need that, and Yang is helping us right now to model our data. Have you ever heard about the Yang data modeling languages? It's very common, right? And it's getting more popular because as a network engineering background, not a software developer or programmer, when I met with the Yang first, it was easy to read for human and for machines, understandable, extendable, and it's easy to adapt it to the different formats that in the open source ecosystem the tools are using. And with the emergence of the Yang, a lot of different modern network management protocols developed as well, such as netconf or the other interfaces like GNMI or RESTconf. So what Yang does, as you see on the right-hand side, Yang is a kind of file, kind of like a YAML-based syntax. It helps us to model our data, either for configuration that we have on our router switches or states, even for operational data as well. So we know all the data that we are going to deal with Yang file. It is structured, it represents the hierarchical way of structuring the data, and it shows the relations between the different network elements. As an example, if you have the OSPF as a container, within the OSPF container, you will be able to see what the elements matter there as an different multiple interfaces. That is represented by list statement in the Yang. And within that interface list, you will have a single node data called leaf, and it will be your IP address, for instance. So the good side of the Yang also, it is easy to be formatted and encoded in a different formats, like data formats like JSON or XML. And along with that formats, we can use different types of data types. Like it can be a built-in, a lot of like a strings integer, but as well as you can create your customized data while you want to create your own Yang files. Many vendor has their own Yang file, but Yang files also not modeling the vendor-specific operational configuration and state data, but also vendor neutral such as IETF and OpenConfig has their own data models. So this is the actual example of the IETF interface Yang module. The Yang files can come as a module or sub-modules. They can be integrated. So it provides us a flexibility to deal with the single Yang file when we design or define the parameters. They can interchangeably used. One sub-module can be part of the another module. And we have the header statement that explains the name of the modules, belongs to what, and then revision for versioning. So that header and revision statements provides uniqueness to that Yang model. And then on the right-hand side of the screen, you will see again there's a container interface. Along with that, it will follow up the other associates. Okay, we have the structured data. We know if I want to do the BGP, configure the BGP, what I need to use, all the parameters, network elements, fine. And then you want to use your systems, open source systems or northbound systems is using XML data encoding. But at the other part of your network, maybe the same similar router that you have to use the configure the BGP may need a different data encoding. It might be a different application and it may use the JSON. So Yang file as a source of truth provides the consistency between the different data formats. So this is very flexibility for the network operators. Okay, so the emergence of the Yang as a data modeling language has facilitated development of modern network interfaces, which are, you might be all familiar or heard about that, NetConf, RESTconf, GNMI, gRPC, all those are the modern network interfaces leverages the Yang to provide connectivity between the software's tools and your network devices. By using these model-driven management interfaces, what we are really achieving is we have more dynamic, scalable, and automated way to interact with our networks. So this also shows that the shift from the traditional CLI-based management to more dynamic management era. So how many of us used just the NetConf to, configure or retrieve some data from the network? Do we any of us that utilizing the NetConf today in our network? Perfect. And how many of us using GNMI for streaming telemetry? Your life is GNMI every day. Perfect. Okay, so now what we discussed that the fundamental thing is structured data. We have it. Yang helps us to model the data. And then it also, with the help of the APIs, let us to put the communication perfectly between software and networks. And we have the network management systems, protocols, such as NetConf. Let's see the most common ones, NetConf. NetConf is developed by IETF. It has its own standards. And the main goal is having a mechanism to set up a connection mechanism to install configuration from the client towards the network. So it is rely on the Yang and the data encoding, it has an XML. It is session-based At the transport layer, it uses SSH. A stateful connection, which means that when the client initiates the connectivity towards to network, that session will be stateful, and during that session, we can operate multiple tasks until we tear the session down. At the messages level, netconf relies on 3 messages. The most important one is the hello message. Hello message is like a handshake, TCP handshake. So the client sends a hello message, then your router or your switch reply back, hello reply by listing the all capabilities that he has. And then based on the other RPC messages, such as RPC request that you can use for the operational level, use the get to retrieve the configuration state data, or use edit config operations, and all in the using the body format and XML encoded. And netconf is more reliable compared to other network management interfaces because it has a lot of mechanism kind of using the different data stores, candidates running, intent, operational, and then you will able to verify as well as commit your configuration after it's verified. So we have to tear down the transport session by the clients, and then for the next time, you need to start again hello message to set up the session. RESTconf, same as netconf. It is IETF developed protocol. It is rely on the RESTful API. Rather than having the stateful session, RESTconf doesn't, session based, and it's stateless. At the transport layer, it relies on the HTTP, and at the message level, he uses the standard HTTP methods. Compared to netconf, with RESTconf, you can use JSON data as an encoding format, and then XML as well. But the netconf is only XML. So some of the vendors support both management interfaces, some others not. It depends on, what are the options that you may have. You can prefer the netconf or RESTconf as well. All right, so the main blocks that we created, structured data, network interfaces, and then now let's talk about the open source ecosystem. Pretty much, you heard about the Ansible. Ansible is written in Python. It provides the mechanism. It's an automation engine to install your applications to the servers or manipulate the configurations in a different way. It comes with the collections, which is predefined actions and tasks for you. But also each vendors, not all of them, but many vendors has their own Ansible plugins and Ansible methods. So if you want to use specific tasks on Cisco, it's available publicly for you. You can use that Ansible module and plugin. So the goal here is Ansible is also flexible. It comes with the plugins and methods that allows us to communicate with the network devices using netconf or using JSON RPC or preferred communication method. So the main framework for the Ansible, you need to define the inventory file, which are the targets, network elements that you would like to communicate. It has the playbook. In the playbook, we are actually defining the all tasks that we would like to perform. And thanks to Ansible methods and modules and plugins, we don't need to, the program how my client will talk to a network device using the certain protocols. So it supports the netconf, RESTconf, and HTTP, and so on. So the first one is Ansible netcom and netconf config modules. It helps us to utilize the netconf when we communicate with the router. At the end of the slides that you see that Ansible used the SSH for the netconf. and on the next slide, we will see the HTTPS for the RESTconf. So what we have, we actually have, again, I'm pushing the red one instead of the green one. Let me keep my finger on this. So the connection is the plugin, and the netconf config is the module. All you need to do is, using this predefined available modules and plugins, and just add your configuration parameters in the XML format for netconf. So same for the RESTconf, modules is available. The Ansible netcommon RESTconf config is the distribution of the Ansible content, and it comes with the plugin. Here is the plugin is connection HTTPI, and it allows to use the URI module just to define your URI for the target endpoint you would like to configure. And the body, of course, will be the RESTconf. It will be given in JSON or XML formats. Okay, so Ansible can be leveraged for many, many use cases. We have also Python. Python has a lot of library, and if you think about the network automation, using the if and then framework, you can do whatever really you want with the Python. So in this example that I just would like to show, only for the netconf connection, a lot of libraries, NCC client is one of the libraries that allows the clients to use Python to make a netconf connection to the network. Ansible is also, I said, written in Python, and NCC client also used by Ansible for the netconf plugin. So you see that this is the basic Python script, and all you need to do is just define your configuration data, the body of what you exactly push to the network devices. Okay, so we talked about the IETF and IETF-based standards for the network management interfaces, modern network management interfaces, and we have the Google. So Google also developed a modern, dynamic, and very effective network management interface, or a protocol called GNMI. So G here stands for the gRPC. gRPC is the unique RPC that developed by Google to have communication between the microservices. And on the modern network devices, we as vendors leverage this GNMI interface to be able to communicate with the routers or with the networks using the GNMI as an gRPC transport protocol. So the flexibility here, gRPC at the RPC level, it communicates with the devices using the protobuf encoding. It's the specific for the developed by Google binary data serialization. But also, at the wire level, protobuf can be encoded in different data formats based on your, the flavor that you want to use. JSON IETF, protobuf, XML, or just JSON. So what the GNMI does? GNMI is in services, and it comes up specific RPCs. Kind of the main RPCs that GNMI services uses, capability, which helps to request to the router and send me what the capabilities you have in terms of the GNMI, like what the encoding that you're supporting, what are the Yang models that you are rely on. And we can use the set RPC to update the certain elements in the network devices. We can use the set, with the set, we will able to get the specific data status or telemetry data. And then subscribe is the modern way of streaming telemetry. We can subscribe to the specific data to be able to retrieve the counters in an the defined sampling intervals. So pretty much GNMI today used for the telemetry streaming, you can do the configuration with the GNMI. But the main differences between, let's say, a GNMI and the netconf, GNMI is directly communicating with the running data store. So you don't have a capability like netconf has to validate and commit your configuration before you make that configuration actually running on the router. So we talk about the open source tools. Perfect. The open source tools came for netconf and resconf to use with Ansible, for instance. But for the GNMI, our colleagues developed the CLI tool that allows us to use GNMI. It's open source, stands for GNMI CLI, let's say. It has CLI interface, and then pretty much it runs all the capabilities that GNMI provides you. You can do the configurations based on your requirement to communicate with the network. And actually, how this does, before that, actually, it is donated to OpenConfig, and it's right now open source and under the OpenConfig. So let's see, have a quick demonstration how this GNMI on my system that I downloaded and installed it from the open source, from the web, and running as an application on my server, on my local PC, let's say. And then now I'm doing the demonstration for CLI. The capabilities provides the encodings and the model information. For the specific counters in packets, for instance, I wanted to get it like a one-off action. But also the router name R1 right now, I just used to set and update the name as a nanoc. Right away, it's changed directly to the running data store. And then now, specifically subscribing, we can use the configuration file to show multiple targets that we want to subscribe. And we define the sampling rate. So once I subscribed, every 3 seconds, or based on the subscriber sampling interval, you will be able to get the all data within that time interval. Another modern management interface developed by Google is GNOI. GNOI specifically have microservices for operational tasks. The operational tasks like system-wide, managing the files, connecting and getting the logs with regards to your hardware status. And also, you can just do the system-wide operations by using the GNOI. The main use case that we can give an example for the GNOI is software upgrade. My colleague Saju, during the last NANOC, he did a great presentation and tutorial about the GNOI with the software, easing the software upgrade. You can refer that for the more details. But if you talk about the basics for the GNOI, GNOI help us perform the pre-upgrade health checks by using the health C RPCs. We can use get the config with the file RPC, get config, and then back it up. And then software transfer, activate, and verification as under the OS service with the specific RPCs. You can install with the, like I showed with the GNMI, with the one-line CLI command, you can install the certain operating system to your network device and then activate it, and the system will be upgraded after reboot. This is the very common use case that GNOI is utilized today. Okay, so we're getting close to the demonstration, the exciting part. Pretty much, we just touch base the all blocks that we can leverage the automation framework. Now, let's have some experiments and how we can do that. Has anyone heard about the container lab? That's great. That's great. Melissa, what you are really testing on the container lab? Okay, so here we're going to talk about briefly container lab, and then after showing the all aspects of the container lab, we have an end-to-end automation, even deploying, commissioning our lab with the help of the container lab. So the Container Lab is CLI platform tools that we can set up containerized systems. Many of the network or vendors right now came up with the containerized operating systems. If you don't have the containerized version, there is also kind of another project on the GitLab. They can convert the VM-based operating system to containerized version. So, Container Lab, it's open source. You can easily deploy it to your Linux platform. It relies on the YAML template. What we do, we define the number of nodes, type of the nodes, bring it up, and then logically creating an wiring mechanism between those network devices. As an example, one of the basic lab topology, we can say, the topology consists of two nodes with the images that, like a containerized image running as an under the Docker container image list, you can see. And then we would like to have two nodes up and running and then having wires between that. All this defined in the Container Lab YAML file. And pretty much today, we have a lot of vendors operating systems supported with Container Lab. Again, some of them containerized, such as SR Linux, but if it is not containerized, it can be also containerized by using VRNetLab. So it is, yes, emulating the different nodes. If you look at that as an example, we would like to set up a multi-vendor fabric setup environment. Not only the routers or switches, but also we can use the Linux hosts to be able to use the applications tap onto that. As an example, Ixia or iPerf on your Linux host. So we have the YAML topology file, list of the nodes, and all the images, and then the links that logically we want them to having as a logical connectivity between the nodes. So I have my Container Lab, all the images ready in my server. Let's see how the Container Lab easily and very fast just deploy all these things. With the CLI command deploying my, referring my topology file, the Container Lab starts deploying the oldest things, creating the links between them, and then bam, with the all management IP addresses, logical IP addresses, rely on the Docker, your setup is ready. Okay, so now Container Lab will help us to commission our lab. We will have the actual routers with regards to that architecture you see on the screen. Then we will start touch base all that blocks we talked about so far. We're gonna use Ansible and Python to configure the interfaces or basic parameters, and then the services such as the protocols like BGP, and then set up the EVPN services. And then we will see within the Container Lab how we can, with the one file, integrate all these hardwares, emulated hardwares, GNMI-C to collect the data over the GNMI interface, and as well as integration of the GNMI-C with the node-bound systems such as Grafana and Prometheus for the visualization and monitoring our network. Everything will be in one topology file, and Container Lab help us to integrate this. So in my folder, I have the three that you see. The Fabric CLab YAML is the main topology file. I will show you the Python script that using the JSON RPC for the main configuration parameters using the Python. And then I have the playbooks listing all my tasks to set up protocols and services with Ansible. And in GNMI-C, it actually, GNMI-C YAML file that show us what exactly the targets that I would like to connect and subscribe, and where to data I will send to the Prometheus. And then the Grafana data source will be the one just saying, okay, I am expecting the data from Prometheus, and then I will visualize all those metrics for you. GNMIC can be deployed in different flavors, but we're going to focus on today having the Grafana, Prometheus, and GNMI integration. So let's have a look at the Fabric CLab container lab YAML file. This is our everything. We all define the lab name, management IP addresses, the kinds of the network elements from the different vendors. So all goal is to emulate this topology on the screen that you see as an leaf spine, having the clients as an representing the hosts. So you see the clients that just the Linux images, containerized images that you can utilize. In the my main container lab YAML file, I'm also defining the Prometheus. It is containerized image. So all of those, when I execute the container topology file, all of those elements will be deployed and then will be up for you. And the last, of course, we have to define our, the logical wires between the network box elements. So the second file is GNMIC YAML file. GNMIC pretty much that used here for streaming telemetry. You can have a GNMI configuration file to say if you want to use GNMI connectivity to certain node, here is the username, here is the port name that you can use, and here is the all credentials. You can define everything else in the one YAML file. And you define, this is the node, I want to go that node, and I want to exactly subscribe for path A, B, C, like the status of this counter, status of BGP peering. All can be defined in the single YAML file. So I'm just defining my targets, leaf 1, leaf 2 are in the fabric. And then I'm defining the subscription, these and that. The subscription is an XPath format relying on the Yang file hierarchy. It says you can use exactly this hierarchy to get operational state of the interface. We will have the network interfaces, which is representing layer 2 services. And then for CPU, memory, you can all define the paths, and as well as the streaming mode and the sampling intervals. And GNMIC using the Prometheus as a destination to send the metrics. Okay, so the Python, it's the JSON RPC. The JSON RPC uses one endpoint. And we have the all data using the set method sent by my Python script towards to my node. All the parameters that you see, data, body, is actually rely on the same hierarchy that you can get for XML encoded or get as a JSON encoded. And the source of truth always is the Yang file. Okay, so now the Ansible example, we're going to push the all the services, basic configurations such as the BGP, IBGP, eBGP, and then we will start tap onto that creating the eVPN services and our VXLAN tunnels. So we have the inventory file, which has the list of the network elements that my Ansible client is engaging to. And also it says, here is the method and plugins that you're gonna use. I'm using here the Ansible Net Common HTTPI because for the nodes that Nokia SR Linux operating system, it will accept the JSON RPC methods. Okay, so now we have the all files. Container lab is ready. Let's start the deployment as an end-to-end. First, we start with deploying our fabric by container lab. All the fabric spine leaf nodes deployed. It's up and ready. Now I'm connecting to one of the leaf to show you there is no really Ethernet interfaces configured yet. We have only by default the management interface, but not any Ethernet interfaces. What I'm going to do, I'm using the Python script, which pushing the all interface information to my node. And it's using the JSON RPC method. Now, with the execution of the Python, there is no errors came up. That means successful operation is done. I am very sorry. There was an... Yeah, I need to do more practice. Okay, just for your attention, again, get familiar with the first 10 seconds. We should have AI to manage all those things for us, Mao. Yeah. So this execution is block by block, but you can have an bash script to do these things for you in a single shot. Perfect. Now let's go and then check on the leaf that actually Python script push all the information with the JSON RPC and how the interfaces looks like right now on my router. It will take like at least 30-40 minutes if you would like to do it manually with CLI, right? But with the one Python in a seconds, it's just configured to all interfaces that I would like to have on my router. So I'm checking my router right now for the BGP. There is no output because BGP is not configured yet. And now I would like to go my playbook and use the Ansible playbook to configure, starting from the underlay configuration, BGP, IBGP, eBGP, and then also top onto that, set up my overlay configuration for EVPN, VXLAN tunnels between my services. So the Fabric service YAML file, this is the a CLI for the Ansible, how we execute our playbook. It starts implementing the all tasks that I defined in my playbook. One single playbook. It is configuring right now the eBGP on each networks in my fabric. Setting up the layer 2 and layer 3 services as a part of the EVPN. And then the necessary VXLAN tunnels. Now, at the end of playing my book, then I will get the results, everything else deployed and up and running. So now in my node that I would like to confirm that Ansible did the old job that I was looking for. I see that all the BGP peering is up and there. That's great. Now I would like to check one of the layer 3 services that I set. It is up and enabled. And now for the VXLAN tunnel, I would like to see it is really configured as I want it. Perfect. Tunnels up. Now I can start checking the data. On my router, I can use the CLI to see if there is any data, any traffic in my router or interfaces. So this is the CLI command that shows there is no traffic rate right now. It is really 0 because I'm not sending any traffic from A to B or B to Z, wherever. You see the result is 0. There's a strong, really powerful command on our router, PWC. It gives you the path that you can use for the GNMI when you subscribe to get that counters. So this path, the traffic rate path, now we're gonna use it on GNMI to subscribe that information, that path. As you see, this is the whole command line. We are subscribing to paths. There is no data that I'm getting right now. No traffic is running. That you see that in bit per second is 0. Now, the Linux client that I deployed with Container Lab having an iPerf. So over my EVPN services, I started traffic, and you see that the up screen, top on the screen that shows the statistics is changing. I subscribe that data for every 3 seconds, I guess. Now it is changing, and I'm monitoring or getting the telemetry data from my node. Once the iPerf stopped and your subscription says, okay, there is no traffic, you need to explicitly disconnect the session. Okay, so we collected all data. It is, we can collect the data by using the GNMIC, I mean, subscribe. And then let's see, we need to, let's see how we store that data in a time series database. As you know, the Prometheus can take that action for us. So Prometheus, with the container lab topology file, we just defined that GNMIC will send the data to the Prometheus. And Prometheus can see GNMIC as a service. If you look at the service that GNMIC is there, what are the time series database and the values metrics that I am getting? We all configured those things in the GNMIC configuration file. What are the paths that I subscribed? What are the metrics that I would like to stream using the GNMIC? You can go and then check all these metrics on the UI of the Prometheus. But what we really would like to do, having a nice visualization, thanks to integration with the Prometheus and Grafana, whatever the data that telemetry GNMIC got from the network, it will be visualized on the Grafana. So you see the old state paths that we told GNMIC to go and then collect for us. Now you see all the data that's stored in the Prometheus can be visualized, like the status of the nodes, the counters, CPU and memory usage, and then the traffic rates between node A to B. All can be like visualized in a nice way, as you see on the screen. So this is the overall approach, having the fundamentals for network automation and then leverage the open source tool to set up such a nice topology like we just demonstrated. This was scaled up to 50 or 60 nodes with Container Lab. Now, let's see how we can just scale this beyond the single node. And in that session, the next session, sorry, my colleague Mao will show us the fundamentals and as well as demonstrating how we can scale up. I will take the question after Mao's session. So Mao, please welcome to stage. Thank you so much.
Probando. Testing. Yeah, okay, perfect. Thank you. Okay, we're going to talk about Kubernetes. For anyone that is familiar with Container Lab, then I saw that there were many people actually working with Container Lab. Kubernetes is, well, it's a mix between Container Lab and Kubernetes. And then many people is asking, why you need to mess something so good like Container Lab and put it in Kubernetes? Because many people doesn't know really what is the value of Kubernetes more than just all the trouble that you can have putting applications and try to monitor the network that is pretty also challenging because you have the internal network of the Kubernetes, you have the load balancer of the Kubernetes, and outside that, some of the things are connecting through BGP from inside the Kubernetes directly to the network. Okay, and then the idea is of putting all this together is we need to scale the container lab. When I started working with the labs, virtual labs, and I think everybody is very familiar to trying to do labs with virtual servers. Just one physical server, probably, I remember that I had a lot of issues to run more than 4 or 5 routers, virtual routers, inside one physical server. It was very challenging. And do the network to interconnect everything also was very challenging for me. The container lab for me was a really great answer to make the things easy. I can destroy everything and build everything back in just minutes. It's very, well, the hard part of the, I would say the container lab is you need to have the container image of your network router or instance, but many vendors are actually providing that right now. And then I got another problem is, I think my biggest container lab is running about 50 instances in just one physical server. I have a core network and I have 2 data centers with a solution. And I was trying to test segment routing, but I needed more. I needed to test a lot of more things. And my first problem was to try to connect one container lab in one server with another container lab in another server. It was a little challenging to make that work because everything in container labs is working with virtual wires, and you can't just go and extend a virtual wire from one server to the other. It's pretty hard. Then container lab starting to work with Kubernetes to make this happen. And then I don't know who, I know that it wasn't Karim. I don't know what person actually did that. The good thing of the open source that anyone can provide a solution for something, just forking. They can fork the project from GitHub and put whatever code they want. And they put the name of Kubernetes. And the idea of that is now I can extend my container lab among many physical nodes using Kubernetes like my platform for that. Then I don't need to be worried about how they are going to be connected between each other because actually the person that did that replaced the virtual wires with VXLANs and using the internal network of Kubernetes in order to solve that. And it's working really good. And I can put more than 100 devices or virtual devices in a Kubernetes cluster for my lab. And I didn't need to be worried about to interconnect different physical servers. That was actually very, very nice. And it's all in 2 minutes. I wasn't expecting that to be so fast, to be honest. Another thing that I didn't put in this slide is the CI/CD that you can start all the concept of GitHubs that the Kubernetes with the APIs, and because they are using custom resource definitions in Kubernetes, it's a very technical concept in Kubernetes, but the idea is now through the APIs in Kubernetes, I can control everything in Container Lab or in Kubernetes. And I can add, remove instances, everything from the APIs in Kubernetes, and I can connect that with GitHub Actions. And then now I can have a CI/CD from GitHub directly to my Kubernetes, and I can use my single source of truth directly in GitHub and have collaboration between different other people. And GitHub is amazing when you need to have more people to not mess up with your source of truth. You can have that in your main branch protected, and they need your approval in order to make any change. And that, for me, at least this is cool, and give me a way to control how I'm making changes on my lab. Okay? And GitHub Action is doing everything for you, going to the Kubernetes and deploying everything. That is also very, very, very cool from this solution. But I'm not covering that part. Maybe I should do a presentation later about that. Okay. I'm coming from another presentation that was just 30 minutes, and I feel like I'm cooking for my kids. So sorry for the interrupt. I know that I have more time, right? Perfect. And then it's only 20 minutes, by the way. But I felt like cooking for my kids when I'm doing pizza. I like to do pizza. Then take me like 24 hours, or I need to wait 24 hours with my dog, and that I'm doing the day before, and then just to build the pizza, to heat up, the pizza oven, take me like 2 hours, and my kids are eating that in 5 minutes. It's like this presentation, you work on this like hours or days, and then you're just delivering this in 20 minutes. It's very funny, but I'm feeling that that was my feeling in the last presentation, by the way. But okay, going back to the presentation. And well, here is what I'm going to have for Kubernetes. I'm doing the demo. I put some slides, additional slides. It wasn't my intention at first, but I'm going to show you some of the basics on Kubernetes. You're going to see a lot of information, details, but it's not a big deal. Believe me, it's very easy. At first, it's a little hard because if you don't understand the concept of Kubernetes, or you never work with Kubernetes, it's going to be a little hard at first. But believe me, as soon as you understand that, it's going to be very straightforward, and it's going to be a very useful tool for you. Then, if you want to create your digital twin now, let's say you have 200 devices in your network, now you can use this solution to make it work. Because before that, you were restricted to work only in one server. Okay? And then basically, what you have your Kubernetes, you are pulling information, the GNMI from your devices, and then using my SDN controller. In this case, it's NSP, but could be anything that can support GNMI in order to go and extract the information. And NSP is using GNMI-C, by the way, in the backstage, if you didn't know, but using open source. And we are pulling that information, putting that in Prometheus, or leaving that information available that you later on you can just put it on Grafana. But it's the same thing that you can have many other applications. It doesn't need to be only one application that is doing that. You can do that with GNMI-C. You don't need to buy a product for that. But what I like from this solution, the SDN controller, you have a unified telemetry model. Then it's not dependent of the vendor. You can have pulled information from many vendors and have a unified model that I can apply to one chart. And then I don't need to have different dashboards for every vendor. You can put everything together in just one dashboard because of that. And you did a really good job with the Django. I think everybody knows about that right now. If you're familiar with a container lab, the only difference you're going to have right now is when you define your topology, you need to put a header that is the Kubernetes header, saying in what namespace you're going to put your lab. Kubernetes use namespaces like pointers to split the teams in different areas. Then you don't want one team messing with their own lab. Then in that way, you can have control of what team, even from GitHub, what team is going to work with one lab and what other team is going to work with other lab. Then you can have multiple labs in different namespaces, and you can have control of what every team and what lab they're going to actually start working on. Then this is the namespace. This is a very important concept, but it's just a pointer. It's nothing. It's nothing else than a pointer. And all the connectivity is happening with VXLAN, then you need to say that to have this information. And after that, the definition, everything else is exactly the same like any topology file. It's not changing in anything. Okay? Then, when you have your two Kubernetes, you have your Kubernetes node, and you have your instances. The instances they're going to be deployed in any Kubernetes node. Okay? Unless you create affinity rules, you don't need to do that, unless you really need it. But the different instances are going to be deployed in different nodes. Even if one node is failing, all your instances are going to be moved to another node. Then it's going to be very resilient too. Okay? If you have everything in just one physical server, you're going to lose your lab. But in this case, Kubernetes is going to take care of that, and it's going to move it to the rest of the nodes. And it's going to spread, the load, the workloads in different nodes to make it even. You need a load balancer. It's just a piece of software that is very easy also to install to expose the management interface of every instance out of the cluster. For example, for USDN controller or for UNMIC instance. Okay? And between the different instances, they are going to be connected through VXLAN instead of using virtual wire. But from the point of view of the network instances, they are not going to see the difference between one or the other. Then, how you do a setup of Kubernetes? You need a Kubernetes cluster. You can create your own Kubernetes cluster using kind in one server. If you want to try first and you don't want to bother acquiring more servers, you can start first putting your Kubernetes cluster in containers using kind. And then you can add the load balancer. In this case, I'm using kubevip. You need the Helm. The Helm is the regular package installer for Kubernetes. And you also have a tool in Kubernetes to convert your current topology file and add the headers that you need for the Kubernetes. It's going to take care of everything. And then you install the manifest using, for example, kubectl. Then what is Kind? Kind is an open source project that you can create a Kubernetes cluster based on containers. That way, if I want to try something, I want to have the experience, I don't need to put too many physical servers. I can just go with containers and have my full experience of Kubernetes cluster before to go more seriously with that. And then it's based on Go. It's very straightforward to install. Probably you need to change just the path in your Linux system, and that's it. And you can start creating your cluster. And for that, you can define also a configuration file. You can define how many control planes, well, 1 or 3 is the standard. And then you can put how many workers you want. And over that, then you can create your Kubernetes cluster using kind. Just be careful with the registry, because when you are starting something, for example, if you have your container images of your devices or for any application, and you want that to be working on that cluster, you need a registry. If you don't want to bother yourself creating a private registry, you can just go and use kind load and start loading the images directly on the Kubernetes, and that's it. But remember, you need to do that in all the nodes. Okay? Then don't bother yourself with the Kubernetes because it's online, unless you need a proxy to go outside. Then you need to set the proxy, but it should be very straightforward too. The kubevip, the load balancer, is a very simple load balancer. I don't use kubevip so much. I use MetaLD normally. This is my load balancer. But in this case, I use kubevip, and it wasn't a big deal to install that, to be honest. And can work with the ARP, or you can use that with the BGP. In the case of ARP, you need a virtual IP. And in the BGP, it's going to require a little more work because you need to create the BGP peering and everything. Then, if you want something very simple with kind, just use the normal one, that's ARP. And then you can bother yourself when you do your massive Kubernetes cluster for your lab. Then you can put BGP, probably is going to be more useful for that. Okay? And I just put many of the different commands that the Kubernetes documentation is giving me, and I put it just in a script. The only thing that you need to change there is what is going to be my segment, my subnet segment for my load balancer. How my IP is gonna, the instances are gonna be exposed. What IP segment I'm gonna use for those, okay? And basically, the rest, you can keep it the same. Just change the IP depending of your situation. If you're using that kind of sort of a private prefixes, or you need another different, but everything depends if you're going to have your genome IC or anything using that lab in the same server, or it's going to be from outside. It's going to be from outside, probably you need to create the routes to go to that Kubernetes and to all the nodes in that Kubernetes. And then you use Helm. You need to install Helm. Helm is just the package installer for Kubernetes. It's a standard one. You just install that. It's pretty easy. I think it's just a very small script that you can just download and run. And then you install the package. You can call the package directly online. You don't need to download that or download the package. You just can call it. And you're going to see then in your cluster that you're going to have 3 pods running as a controller of the Kubernetes. Then if everything is saying running 1.1, then you're good to go. If not, you are in problems. Then Cloudverter, I don't know how you pronounce that, to be honest. But a Cloudverter is the tool that you use to convert any container lab topology to a manifest in Kubernetes. And when you do that, it's going to create 2 files. One file is the namespace. This needs to be the first file you need to run. You need to create a namespace. You can add more things like user accounts, service accounts. If you want to have real control, access control to your lab, you can put more elements than that. And the other file is a manifest that is going to create the topology, and you are addressing that namespace. Then if you run this before the namespace, it's going to fail. Okay? And you need the namespace. You can add extra security if you want, and then you can go and run the topology. Then how can I run that? Then you run first namespace. You run then you are going to apply the topology, and you're going to see all the instances that you have in your topology running like pods in a Kubernetes. Are you seeing this picture? And because you installed the load balancer before, you're going to have immediately, it's going to show you what is the IP address for your management interface that you can connect from outside. Okay, this is automated. You don't need to touch the load balancer and everything. It's going to do it that by themselves. And basically, this is it. This is a video. It's very short. I didn't want to show the whole thing. And I put extra big fonts for everybody to see it. But the idea is, you see there, I have the namespace, and I have the topology there. It is exactly the same in the container lab topology file. I just adding this to my manifest with the header for Kubernetes. And those are my nodes in the Kubernetes. This is kind, by the way. I'm running the Kubernetes directly in containers. There, you're going to see all the pods that are running in this Kubernetes cluster, and you see that lab is in a specific namespace. Because I'm the admin, I can see everything, but you can also restrict access to it to some users. And with that, I'm going to see, okay, I created my lab. I want to see what is the IP address that I'm using. That is going to show you all the ports that I'm exposing, and it's going to show you the internal IP of the internal network of the Kubernetes and the external IP that I'm using for the load balancer to access this from outside. And then, thanks to that, I can just go and connect to that device from outside and see if actually it's working. And you can see that actually the neighbor is there, and it's actually all the devices are connected between each other as I define in my topology. to create or destroy everything is as faster as a container lab. It's pretty easy. The big deal is to start with it. But as soon as you understand the logistic about working with Kubernetes, it's going to be very, very easy. Then what I did after that is, okay, let's test this Kubernetes is actually working. It's not failing all the time, because that was my, okay, it's easy to make it work, but it's going to stay there. It's going to work. As I start connecting the devices, it's going to keep running. And then I put my NSP solution, trying to do the inventory of those devices. And it was using GNMI. Yeah, I love GNMI. I hate netconf. And then I'm using this for the inventory. Sorry, now I'm running the video. And I just put some policies for the discovery. You can use, I'm using certificates for this, because I wanted to try also the secure connection between the devices and the monitor system and the network management system. And because I have them right now in my inventory, now I can create telemetry subscriptions and start pulling information from those. Now I want to say, okay, is it really working? Is I'm pulling that information? Then you see the inventory is giving you all the details, like any normal device. And I try to see, okay, let's see if it actually is going to pull some telemetry information directly from there. Well, I have many subscriptions, sorry for that. I should have cleaned this a little more. And then, yeah, it's pulling all the information. You can add the counters you want. This is a unified telemetry system. It doesn't matter what is the vendor that I have behind. And it's going to start pulling the data from the interfaces and so on. Then it's working. But again, the Kubernetes is just a name. It's not that hard. It's not that. Don't be scared because you have Kubernetes in the middle. Actually, make the things much better, more automated, easy to maintain, easy to control. I don't have other people messing with my lab. Okay, because I remember we were sharing a server, and somebody else tried to run another lab in the same server and mess with my lab, and I was actually doing a presentation to a customer at that moment. Then now with Kubernetes, that is not going to happen, because I split, the things, and I can have my own lab, and I am the only one that have access to it. Okay, and share about it. This is additional information. You can find information in the online, and you can also read about Container Lab. And there is I did a Kubernetes 101, 1 hour. If you want to take a look at that. Is if you want to understand how Kubernetes is working, and I did that for network professional to explain how is the network working inside. Okay, and I think that's it. You removed my meme at the last slide that I put. I put a meme. You remove it. Yeah, it's not my meme there. Okay, questions?
Yeah. Any questions about model-driven?
Hello.
Modern network management. You're not allowed to ask. You know everything else already. Okay.
So I had a question. So you talked about with the playbooks earlier. Are there playbooks that, like you just talked about, are there playbooks with Kubernetes yet, or just with Kubernetes?
Ooh,
Or just
combo question.
Well, it doesn't matter if you're using Kubernetes or Container Lab, because from the point of view of the Ansible or any other solution, it's going to be the same. Then you can use exactly the same playbook that you have for Container Lab. You can use them also with Kubernetes.
Okay. And you don't need to change anything in the namespace at all, or is there differences there, like when deploying?
Sorry, could you?
Sorry, you need to make any differences in the namespace when you deploy, or?
No, doesn't matter, because from the point of view of the GNMI, for example, C, you're gonna be an IP address. You're gonna see an IP address, and that's it. You don't even know that it's running in Kubernetes or in a namespace.
Thank you.
You're welcome. Yeah.
Yeah, one more.
So
Another
one.
I told you to not ask
You know
any
all the
questions.
answers.
No, you always ask me. You always ask me to ask questions. So you talk a lot about GNMIC, right? You have in the last couple of sessions that you've provided, specifically to Mao. And we're kind of focusing on the Nokia products, but how do you see the industry actually moving towards a GNMIC type of, or I should say gRPC stack? Not just for Nokia, but I'm talking about Cisco, Arista.
Modern
where do you guys
streaming
see it?
telemetry.
Model driven. Thank you. Model driven.
Yeah, well, if you GNMI, no, like model-driven also
I would
netcode.
like to see. I mean, we haven't had a chance to really deep dive into the gRPC specs and then how the GNMI services or use cases that leverage today. But I see seriously move, not maybe for network configuration, but for the streaming telemetry. Many network operators, small service providers, they really start utilizing the gRPC with GNMI interface for monitoring, troubleshooting, and visualization. It is very flexible. That allows us, as we have shown with the all open source tools, that you can do the perfect, monitoring platform for your network. I see, specifically with the SNMP's limitation. Now people start well understanding the modern streaming telemetry aspects.
Much more efficient. Okay. Thank you.
You're welcome.
Thank you.
Well, I don't have too much information about the market, if it's actually transitioning to ENMI, but personally, NetConf took me like 2 minutes to pull data from the switch, and with GNMI, it took me like 2 seconds. And then, why are you going to use NetConf?
It is different. It's not an apple and orange.
Well, I just say it.
Because NetConf itself designed to address the challenges. For instance, you're dealing with the big networks, you're configuring the stuff. If there is a one-click mistake, then you directly configure the whole network and impact the rest of the whole equipment. But NetConf creates a transactional configuration approach. So before, with the data stores, before configure and make the things operational, I do my candidates config, validate. If everything is fine, then boom, I will push it.
But it's going to take 2 minutes. Well, anyway.
It's actually like...
I understand that. You can have the candidate. I don't have that in GNMI, and then probably there one thing's another, but...
I love GNMI.
What you're talking about NetConf? You shouldn't be talking about NetConf. Okay.
Right.
Any other questions?
More questions?
No?
Perfect.
Okay. Thank you very much.
Thanks so much.